This is the device. This is called wrench. This wrench is generally used to loosen the nuts. In here, there's a nut. You see that? Okay, I will show you now a nut. Now I will open my
It's
computer.
like a nail.
Yeah, like a nail, but not a nail.
Not really like
Yeah,
like it's.
Let me show you. You will get what nut is. This is used to fix something on the wall or somewhere. This is the wrench. So this wrench is used if you are going to fix it or tighten it so strong. So you should use this wrench. Now, by applying the torque, you are able to rotate. Now, nobody can open it with the fingers. I mean, you need, again, this wrench to loosen it again. So you can fix it. You can tighten it by a wrench, or you can loosen it by a wrench. But in all cases, you start the rotation. Rotation must be started by torque. If you don't produce a torque on this nut, you cannot rotate this nut. For example, right now I'm trying with my fingers. I'm unable to rotate this, which means my fingers cannot produce enough torque. But now I'm going to use this wrench. Then yes, I am able to rotate it. So which means by using this wrench, I can produce a torque, enough torque, and I can rotate it. So now let's go back to this screen. I'm going to share the screen again. Now we will get the equation, how to calculate. In fact, we got it, but we are going to write more detailed equation about torque. So this is the nut, and we are going to try to rotate this nut by using this wrench. Of course, you are going to apply some force in here. This blue line is representing the force applied by your hand. So this force is applied at a distance to axis of rotation. This distance is represented by T. And a force F acts at the end of the range in here, but by an angle of theta over a distance T. Yani, this is distance from force to axis of rotation, and there is an angle between the force and distance, which is represented by theta. So the angle theta is the angle between the force and the distance line. In this case, I am going to use, in fact, the definition of the torque, but I need a lever arm and moment arm. Remember, lever arm and moment arm definition was like this. So I'm going to apply this definition. First, let me clean here. It says the definition. Can somebody read the definition of the lever arm to me?
The perpendicular distance from the axis of rotation to be a line along the direction of the force.
Great. First, you should draw a line along the force. I am drawing a line along the force. Draw as long as possible. And you need to draw a perpendicular distance from axis of rotation. This is axis of rotation. This perpendicular distance, is it perpendicular in here?
Yes.
So then this perpendicular distance, this distance is lever arm or moment arm. But it is not T right now. Do you see here we have a right angle triangle?
Yes.
And if this angle is theta, that angle is theta?
Yes, that's true.
So this hypotenuse of the triangle?
Yeah.
Yes, that's true.
And lever arm and moment arm is the opposite side of the angle?
Those sides.
Yes.
So opposite side is calculated by what?
Yes, sine.
Sine. That's why you should multiply D by sine theta to calculate the lever arm. D sine theta is the lever arm or moment arm for this range. After that, now use definition of the torque. So magnitude of the torque is calculated by how? Force multiplied by lever arm. A force is F. A lever arm is D sine theta. Insert them into the equation. Sorry. So it's going to be F D sine theta. This is the equation which we are going to use to calculate the magnitude of torque. So Ft sine theta is the equation for calculating magnitude of the torque. Ft sine theta. F is the force. D is the distance from force to axis of rotation. Theta is the angle between distance line and force line. So this is the equation. By using this equation, we are going to calculate torque and we are going to solve problems. And one last thing I will talk about, and then I'm going to finish. So according to this equation, Ft sine theta, torque depends on three quantities. One of them is F. Yeah, if you make force greater, if you apply a stronger force, greater force, you can make torque greater. Yani the greater the force, the greater the torque is. Second thing, if you make distance longer distance, yani from force to axis of rotation, the longer distance from force to the axis of rotation, so then also the torque becomes greater. Yani you can produce a greater torque. Also angle. Angle between force and distance is also important. So we know that which angle has the maximum sine, greatest sine. You know, it's 1, is it? Maximum sine gets maximum 1. At what angle?
Yes.
At what angle?
Sine 90.
90. Yes, sine 90 is 1. So when the force is perpendicular to the distance, which means angle is 90. So you produce the greater torque. So the closer the angle to the 90, so the greater the torque is. So once again, greater force, greater torque. Longer distance produces a greater torque. Or if the angle between the force and distance is closer to 90 degrees, so then torque becomes greater.
Teacher,
Yes, please.
but that angle, I mean angle theta can never be 90 though, right?
Why not?
Because we can't have two right angles in a triangle.
So this way, okay, tell me, what is the angle between, this is distance, huh? Is it distance from force to the axis of rotation?
Yes.
How much is this angle?
90.
Yeah, it can be 90. If it is 90, you produce the maximum torque because angle sine 90 is 1. When you are trying to rotate something, you should push that thing at 9 perpendicularly. You should push it perpendicularly so to produce the maximum torque. You should apply the force at 90 degrees to the distance. Okay. Bu kadar yeterli. Yorulduk herhalde. We got tired. Everybody got tired. So I am going to get your questions, then finish the lesson.
Okay, I have a question about the experiment. So
Yeah.
you tried to rotate the knot by your hand, right? But you
Yes.
weren't able to because your force is not enough to make a torque, or what?
Great. Torque is not enough. My fingers couldn't produce enough torque because by using the range, I made distance longer.
By using what? The
By
wrench.
using the range, yeah, range. I made the distance longer.
So the torque was not enough.
Was not enough, yes. It was not enough. My finger couldn't produce enough torque. And after that, I used the range. And of course, range has a longer distance than my finger. And then I was able to rotate enough torque to rotate the knot.
So not every torque is able to rotate an object.
Exactly. Not we will talk it later, not now. It takes, first let's define all the torques. Then we are going to talk about the required torque. We said that according to this equation, Ft sine theta, the greater is the force is, the greater is the torque is. Like what? Like this. Compare these three. We got the same object. We applied the force at the same point, but we applied different forces. First one, F. Second one, 2F. Third one, 3F. So, of course, which one has a maximum greatest torque? Which one is the most torque?
3F.
3F, of course. 3F times T, because all I got is this angle 90 degree for simplification, simple calculation. The first one has a torque Ft. Second one is a torque 2Ft. Third one is a torque 3Ft. So then, first one has least torque. Second one is less torque, but the third one has the most torque. Yani if you increase the force, so of course torque produced will be increasing. The first one is the second. D. The longer the distance from the force to the axis of rotation, the greater the torque is. This case. Now in here, the first force is acting axis of rotation. So if a force acts on axis of rotation, what is its torque?
We don't have torque.
Zero torque. There is no torque. So the first one, zero torque. But second one, acting at a distance of d over 2. But third one is acting at a distance of t. So of course, third one has the most torque. Second one is less torque. But third one is, the first one is zero torque. Zero torque, less torque, but most torque. As d increases, yes, torque is increasing. And third one, the closer the angle theta to 90 degree, the greater the torque is. Compare these cases. At which cases angle is closer to 90?
The
The
third
third angle.
Third one, of
Third.
course. In here, the torque is max greatest. Less torque, least torque, most torque. So least torque in the first one because angle is much small, closer to zero. I mean, if you compare the second and third. But the third one, if you make it 90, it's the maximum torque. Because sine 90 is 1, it gets the sine function gets maximum number 1. So when angle is 90, if a force acts on over a distance t by 90 degree, so it is the maximum torque. That force produces a maximum torque. Even you apply same force over the same distance, because angles are different, so the torque cannot be equal. Torques are different. Least torque, less torque, and most torque. And torque is a vector quantity. Torque is a vector quantity. For that reason, if a torque is positive, the sign of the torque will be written as positive if it causes a rotation counterclockwise. Remember, we did the same thing in chapter 1 too. So counterclockwise rotation for angular displacement and angular speed is taken as positive. So if a force tries to rotate an object in counterclockwise direction, so you are going to get the sign of this torque as positive. If a force tries to rotate an object in clockwise direction, so the sign of the torque will be written as negative. So it is a vector quantity. Torque is a vector quantity. A SI unit of torque is Newton meter. Newton meter, because force is Newton, distance is meter, sine, it's the, angle has no dimension, radian has no dimension. So for that reason, torque is equal to Newton meter is the unit of torque. And a chapter question in your book, which of the force acting on the rod in the figure will produce a torque about the axis at the left end of the rod? So which force produces a torque, F1 or F2?
F2.
F2 is acting perpendicular over a perpendicular distance, but F1 is passing from the axis of rotation. If a force extension passes through the axis of rotation, so then this force cannot produce a torque. Torque 1 is 0, but torque 2, yes, second one, produces a torque F2 times that distance. Simple, but ministry exam question. And one section of question in your book, how does the length of the pedal arm on a penny farthing bicycle affect amount of the torque applied to the front wheel. This is a penny farthing bicycle because one wheel is so huge and second wheel is so small. I think in Britain they have a penny. This is penny. Penny is larger, but farthing is small. That's why it's called penny farthing bicycle. So you are going to apply the force in here. In here, I draw a little larger in here. You apply the force in here, pushing your foot, is it? Your foot is pushing the pedal. But this is the distance to axis of rotation. This is distance. If you make this pedal arm longer, what happens? Distance increases.
Torque.
If distance increases, remember, torque is equal to F times T sine theta. If T increases, torque also increases. That's why increasing the pedal arm increases the distance. So then torque, applied torque to the front wheel increases. But if you make pedal arm shorter, so then D decreases. Decreasing D causes torque to be decrease. So this is the answer of this question. If you make the pedal arm longer, torque increases. If you make the pedal arm shorter, torque decreases. This is the sectionary question. Yes, now we will continue. We will start calculating the torque. It's a wheel, and a force of 6 Newton acts on a wheel with a radius of 1 meter. So radius of this wheel is 1 meter. So this is the axis of rotation. That is R. And R is given as 1 meter. How much is the torque produced on the wheel? So this force acting like this, it's given in the picture. And this force is given as 6 Newton. And this force acts over a distance T. This is distance. Distance T. So tell me, distance is how much in here?
1.
It's 1.
It is the radius of the circle, is it? So 1. R is equal to 1 meter. It's the radius of the circle, the same as the circle. Calculate the torque. How much is the torque in here? What about the angle? How much is the angle between force and distance?
So it's 1.
90. Yeah, it's 1. This angle is 90 because you know tangent line, force is acting over the tangent line, and we know that tangent is always perpendicular to radius. Tangent is always perpendicular to radius. That's why angle, theta is 90. So torque is equal to force times distance times sine theta. So calculate it. So force is 6 Newton. Distance is 1 meter. Sine theta, sine 90, which is 1. So it's going to be 6 in magnitude. But what about the rotation? This force is causing a rotation clockwise direction or counterclockwise?
Counterclockwise.
Counterclockwise. This force tries to rotate this wheel in counterclockwise direction. If the rotation is counterclockwise, torque must be
Positive.
positive. Yes. So this force produces a torque of 6 Newton meter, positive 6 Newton meter on this bicycle wheel. Yes, practice problem. 2A, question number 1. A simple pendulum consists of 3 kilogram point mass hanging at the end of 2 meter long light string that is connected to a pivot point. Calculate the magnitude of the torque due to the force of gravity around this pivot point when the string makes an angle of 5 degrees with the vertical line. A simple pendulum consists of 3 kilogram point mass. So this mass in here has a 3 kilograms. So M is equal to 3 kilograms. Hanging at the end of 2 meter long light string. Light string, and you are going to neglect the mass of the string. So this string is 2 meter long. Length is equal to 2 meters. that is connected to a pivot point. Pivot point means I mean the point which you suspended. This is pivot. Calculate the magnitude of the torque. When it says magnitude, you don't care about positive or negative. I mean, clockwise or counterclockwise, we don't care because magnitude of a vector quantity always written as positive. So in here, you shouldn't be worried about the direction of rotation or torque is positive or negative because magnitude of a vector always written as positive. But calculated magnitude of the torque due to the force of gravity. Force of gravity is Fg, is it? So there must be a force acting on this point mass. You know that Fg is always acting down to the center of the Earth. It's always acting down to the center of the Earth. So we are going to calculate the torque because of this force around this pivot point when the string makes 5 degrees angle with the vertical. That angle is given as 5 degrees. In this case, we should obey some problem-solving strategy in the torque problems. First, draw forces acting on the object. Object is in here as the point mass. The force acting on the point mass is Fg. Because question is asking the torque only because of the force of gravity, I only care about Fg. So I draw the forces, I draw it, and record them. Calculate Fg. If you know what mass is, you can calculate Fg. Fg is calculated by mass times free fall acceleration, m times g. So Fg, let's calculate it. M is 3 kilogram, g is 9.81. So multiply them all, you will get the answer as 29.4 Newton. Yani this gravitational force acting on this pendulum's this mass is 29.4 Newtons. Next, determine the axis of rotation. About which point the rotation occurs? Of course, the pivot point. This is the axis of rotation, O. And determine the distance and record them. Distance from axis of rotation to the force. It is the length of the string. And distance is length of the string, which is equal to 2 meters. I all record the distance. Determine the angles and record them. Angle between distance line and the force line. This angle is the same as this one, 5 degrees. Yeah, if this is 5, that is also 5 according to maths. Your angle is going to be 5 degrees. Angle between the distance line and the force line, which is equal to 5 degrees. And indicate the sign of the torque. We don't care here because it's asking magnitude. So just calculate the torque. Equation for calculating torque in here is F d sine theta. Force is what in here? Force is the gravitational force. So let's write them. Torque is equal to force is gravitational force. We already calculated is 29.4 multiplied by distance from force application point force to the axis of rotation is 2 meters, which is the length of the string, multiplied by sine of angle between the distance line and force line. It is 5 degrees. So when you multiply them all, you will get the answer as 5.1 Newton meter. 5.1 Newton meter is the magnitude of the torque produced by this point mass about the pivot point or about the axis of rotation. Any questions about this?
Teacher, I didn't understand how you determined the distance.
This is force, correct?
Yes.
Where the force is applied?
Downward.
No, where is applied?
To the point mass.
Yeah, great. It's on the point mass. Where is axis of rotation?
The place that you just...
Yeah. So then distance is from where the force is applied till the axis of rotation.
But didn't we see this, the line along the force? Like we should
No.
make a line.
When we are finding the lever arm, when we are calculating lever arm, we do that. But you will not calculate lever arm in calculation. Your equation is F d sine theta. F is the force. D is the distance from where force is applied to axis of rotation. D.
So the distance alone is from the axis to the force itself.
Yes, that is distance. Let's go back to the equation of, in here, look at here. From where force is acting till the axis of rotation is distance, D.
Okay, yes.
From where force acts till the axis of rotation is distance. Angle. The angle between the force line and this line is the theta.
Yes, yes.
Force line, distance line, angle between them is theta. So pendulum consists of 3 kilogram mass hanging at the end of 2 meter long light string. So this is the light string, 2 meter long. Length is given as 2 meters. That is connected to a pivot point. Pivot point means axis of rotation. When it says pivot point, understand that it is the axis of rotation. Axis of rotation. So the O, we represent it by O, axis of rotation. Calculate the magnitude of the torque due to the force of gravity. Question is saying that, there will be a force of gravity acting on this point mass, Fg. Calculate the torque because of this force around this axis, this point, around this axis of rotation. Even it says around this pivot point, which means around this axis of rotation is that point. When the string makes 5 degrees with the vertical, so 5 degrees, this is the angle. It is given as 5 degrees, and then they want you to find the torque. So equation, as we know, torque is equal to F d sine theta. So F is in here, force of gravity. Yes, you should first calculate it. Mass is 3 kilogram. If mass is 3 kilogram, I have to calculate the force of gravity by the equation Fg mg. And we know that m is given in the question as 3. Free-fall acceleration 9.81. So this multiplication is equal to 29.4. We got the force. We will write the force in here. Distance is from where the force is applied in here, to the axis of rotation right there. This is distance. That distance is equal to length of the string. So distance is equal to length of the string, which is 2 meters. Even we know what D is, we know what F is. Theta. Theta is the angle between the distance line, it is the length of the string, this is the line, and the force line. That is the angle theta. It is the same angle with 5. 5 degrees and this angle are equal. So then we know it's 5 degrees. We know distance is 2. A force is 29.4. Multiply them all and get the answer. So torque is equal to F d sine theta. So then torque is equal to F is 29.4. Distance is 2 meter long string multiplied by sine of 5 degrees. So answer becomes 5.1 Newton meter for this. Because question is asking the magnitude, we don't care about the negative and positive sign of the torque for this question.